everyone. Thank you for coming this afternoon. I'm Titus Winters. I'm talking today about refactoring and the impact of refactoring on higher level design features, design structures. This is a reprise of a talk that I gave at CPPCon about a month ago, although in the ensuing month there's been a couple things that we've learned, especially about the refactoring and concepts. Also, we have like a whole half-hour extra here as opposed to at CPPCon, so there's a few places that I've tried to expand stuff. And additionally, it's a much smaller, much nicer, more I don't know, familial sort of audience. Also, there's not a giant spotlight on me and the room doesn't echo. So these are very nice features. I would strongly encourage everyone, if you have questions, do not hesitate to ask, like jump in, interrupt whenever. I would much rather that this be a little bit more conversational and a little bit less lectury. So along those lines, even just before we start, does anyone have any questions? Right? Because you kind of got to build up the question momentum in order to like get anywhere. So, questions before we start? Niall.
What's the title mean?
The title means I had to come up with a title like months and months in advance. But really, like what I'm trying to get at is as we build like more abstract structures from functions and classes and class templates and concepts, how does the choice of how expressive a tool you use impact your ability to refactor things? Does that make sense?
Yep.
Cool. Bryce.
You recently wrote a book. Why and how does the book relate to this talk?
Second to last slide. I will get there, but thank you, Bryce. Any other questions before we jump in? All right. As I will say one more time, please don't hesitate. If anything is unclear, please don't hesitate to ask. We have lots of time. Okay? So, as with so many of my talks, I start historically. In the beginning, in the long ago, code was sort of not organized at all. It's just a protoplasm, big pile of code, right? And for the first couple decades of computer programming, there's just this no structure. You see this in old code that relies on goto everywhere, and even the programming languages of the day that assume that everything has to have a label and a line number, right? And everything is just based on jumping to different line numbers and memory addresses. And we're really letting the abstraction of the processor, the abstraction of the computer sort of bleed into the programming language. We hadn't learned yet at this point in time that it's easier to read and write and maintain code that structurally enforces any sort of invariant, like what values are in memory, what things are in registers, which registers are available, what variables are in scope, none of those things. And so over time, we moved towards a thing called structured programming, which roughly started in the late 50s and came to so completely dominate the programming landscape by the late 80s that now it's sort of a historical note, like everyone just kind of accepts it as table stakes. This was the move that pushed us towards clear-cut structures, like functions with well-defined calling conventions, like these are the arguments, these are the parameters to a function, this is the return type of function. Loops, conditionals. The structured programming movement gave us goto considered harmful. And it isn't that goto is morally evil, right? It's that the structure that tries to replace goto, the more restrictive forms of functions and conditionals and loops, give us invariants that let us reason about code locally. Local reasoning is critical to scale. I can't easily modify a function to accept an additional parameter, like an optional parameter, if I have to know what is in a given register at every point in my program that might possibly be calling that function, right? That would require global knowledge, right? And it's much easier when we have structure that lets us make changes based on only local knowledge. That's very powerful. So it's counterintuitive for some people looking at this that the first 30 or 40 years of programming showed us that adding more constraints and structure, limiting the ways that we write code, actually gives us greater flexibility to write bigger and more expressive programs. And nowadays, we keep building up from there, from structured programming into object-oriented programming, and adding new and more expressive, higher-level structures. We go from functions to classes, and with C++, we go from classes to templates. And now with C++ 20, we're moving to concepts. And I suspect that we may not be at the end of that. I said a few months ago that types are harder to refactor than functions. And some of my colleagues on the committee didn't understand entirely what I meant by that. And so I'm trying to explain that with this talk. But first, in order to say both that types are harder to refactor than functions, we also have to maybe explain what I mean when I talk about refactoring. What is refactoring? And I'm not going to go to a Merriam-Webster discussion or not. I'm going to go to the sort of canonical description of refactorings. How many of you have read Martin Fowler's book or articles from Martin Fowler on refactoring? It's kind of important. It's relatively recent. It's not terribly dry, right? It's an important, useful piece of understanding when you're talking about maintaining software. If you go to refactoring.com/catalog, which is sort of trying to catalog all of the things that could be classified as a Fowler refactoring, you wind up with change function declaration, extract function, inline function, blah, 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 blah. And these are the sorts of things that you could imagine having as a tool in a drop-down menu in your IDE, right? I'm going to drag in, I'm going to select, I'm going to highlight some code, and I'm going to say, pull this out of the current function body into a function on its own and replace it with a function call. Does that make some sense? Right. You're probably familiar with these in concept, if not in name. But there's more things than just that you could do as, oh, my boss just assigned me to refactor the code base, refactor the program, right? You might actually have to change the behavior of something, right? You have some God class in your program, and you need to change the behavior of some invocation of some function in that thing, right? You need to change some business logic, right? Changing behavior is another reasonable thing that you might call refactoring. Adding a default parameter to a function is absolutely, you're making a change to the behavior, you're making a change to the design of your program, you're refactoring. Even a global find replace for an API, right? You find all places that it says, I don't know, stood string, and you replace those with non-stood my string, right? So refactoring, right? Deleting your whole code base. Is it refactoring, right? You don't use that one very often, right? But my question is, these changes, these things that you could describe as, okay, I could make this sort of change, most of the time, that's describing what we're trying to achieve, but is that actually the fundamental unit of change? Or, to be a little snarky, is it the refactoring version of how do you draw an owl? You familiar with this meme, right? Step 1, draw some circles, draw the head and draw the body. Step 2, draw the rest of the bleeping owl. That was not me, okay. So I want to spend a little minute looking for perhaps a more fundamental, what is the basic unit of change? And I think even just looking at this list, there's a mix of circles and owls in what we think of as basic refactorings. Some of these are definitely, I could change 1 or 2 or 3 files in my project, adding a default parameter, at least in a well-behaved code base, should be you're editing, a constant number of files. You're editing the header and the .cc file, right? Whereas find replace for an API is going to scale with the number of files where that API is referenced, right? You're going to have to edit all of those files, right? And those morally feel kind of different. And we're going to run up into limits. We're especially going to wind up needing something more complicated when we're trying to make a scales with usage type of change, like find replace an API, that needs to change across organizational or repository boundaries, right? Like if your infrastructure team has their own Git repo and all of your project teams have a separate repo, your infrastructure team can't just do a find replace and be done because there's code in all of those other repos that they have to work with. And if you're trying to not break the build for everybody, you're going to have to dance a little bit more carefully, right? Make sense? It's also going to run up against this same, or at least similar problem. This is a very Google problem. When you want to change more files than you can commit at once. I have a pretty reasonable estimate that I'm uncomfortable changing more than 2,000 files in a single commit. That number is going to vary wildly depending on your development practices, depending on your version control system, right? All sorts of things. But you should actually, like organizationally, I recommend it's a healthy thing to have an estimate of how much could I do at once if it really mattered, right? Because at some point, it might. You're also going to run into problems with these sorts of single-step refactorings if you're trying to make a change to a library that has compatibility over time guarantees. Yeah, Bryce.
Aren't you all about scale? Why are you uncomfortable with changing every if it's the same change everywhere, why?
Right. Why? Okay, Bryce's question is, Google is all about scale. Why are you uncomfortable changing more than 2,000 files at once? So one, the version control system is a little iffy on it, but I don't know what the actual concrete limit to how many files could be in a single commit. The more germane issue is, I am uncomfortable making any change that hasn't run through CI, right? I'm going to run the tests, right? And the number of tests that are impacted almost certainly scales as a function of the number of files that are impacted. It is also the case that after the tests run, you probably still have to sync to head in order to commit. The sync to head operation scales linearly with the number of files in the change. And there comes a point, especially if you are really big like us, where the number of files in the change is so large and the rate of change in the code base is so high that it is technically impossible to actually get synced to head in order to commit, to say nothing of having fresh test results, and then to say nothing of if you did commit that and it broke the world, how do you roll that back, right? Because you got lucky in getting it synchronized so that you could submit, right? Trying to rush and get that undone, bad plan, right? So like, there comes a...
So what you're telling me is you have a memory coherency problem?
Yes, there's a memory coherency problem. Niall.
I just looked up there to see what was the biggest thing to do in single time, and a guy did 350,000 files and said it worked fine.
Guy did 350,000 files and said it worked fine. Did it work fine after the fact? Because there is also the question of many version control systems in implementation may have steps when they're doing like later revision maintenance work that may scale poorly with the number of files in a single change. It's probably fine, but like it might be a weird blip in your history that's unpleasant to snarf down. And
So tooling that goes through Git history, it basically hangs.
yeah, right. So
That's fine, that works, but not
yeah. So for the video, the tooling that actually works on your Git history afterwards, it basically hangs as soon as it spots that thing. So you can get it committed, and then your repo is dead. So not ideal in any case, right? You may want, just from safety perspective, to know roughly like order of magnitude how many files can you change at once comfortably. Okay? So if a single step refactoring is going to fail or is not going to is inapplicable, what do we do? Oh, actually, first, I think this really breaks down. I've only seen two primary forms of this. There's scale, either we have so many files that need to be changed that we can't change it, or you are distributed across a bunch of different repositories and you inherently have to synchronize across all of those repositories. Those are sort of isomorphic. There's also visibility, right? If you are releasing an open source thing, you don't have visibility into all of the users of that thing, right? You can't just say, oh, I did a global find replace, right, and mean global, right? You don't get to just find replace in your IDE and track down every user of your library and every hidden repo, private or public, right? That's not how that works, right? If you don't have perfect visibility into how your code is being used, it is going to complicate some of your refactoring jobs. Okay, so these are sort of the two major things that back you into this. Google stumbled into all of this because of the much easier one of these, which is scale, right? We have perfect visibility into how our code is being used, which turns out to be much easier to work with than, is a much better feature to have than small but lack of visibility. Tool-assisted refactoring is going to be useful in both cases, right? But when I do tool-assisted refactoring on my super large code base, I see all of the results. The very same tool could then be applied to code bases that I can't see, and I have every reason to believe that it'll work just fine, right? It's the same technology, but it's harder to hit the target in the dark with your eyes closed, you know? So, in any case, if you have scale problems or visibility problems that prevent you from changing an API, the source API and your users in a single step, and if you care about your users, then we're gonna have to find something more complicated to do. Any questions? So, multi-step refactoring. This is, we're going to execute a large, maybe distributed change in a series of steps such that the ecosystem continues to build and function cleanly at every step without preventing people from committing while this operation is going on, and each step is individually small enough to be handled as part of the normal sort of developer workflow. Most steps shall avoid any explicit sequencing requirements, right? I can just treat them as broad, shotgun, easy, like I'll apply change number 47 and change number 53 and then change number 42, and it doesn't matter, right? They're not sequenced. So effectively, we're breaking the operation of some of these single-step refactorings, like find, replace, rename class, into smaller atoms. And I'd say that the basic atoms of refactoring for a multi-step job are things like this. We're going to add an overload or add an alias. We're going to change a caller locally from one function to another in a way that we can locally reason about to say, this has the same invariance, this has the same behavior, same semantics. Change an instantiation from one type to another in ways where we can prove that those are compatible. Remove an unused API or an unused feature of an API, right? All of these are very, very nice atoms because they can be used while only editing a single file or 2 or 3 files, right? They scale very nicely. Other operations are sometimes usable in a multi-step refactoring that depend entirely on the context in which you're executing that refactoring, right? Renaming a type, changing a function signature, right? These have a sort of flexible rubber atom size. They require touching potentially many files at once, but if that potentially many is small enough that you're comfortable with it, then just do the easy thing, right? Don't make it more complicated. So if you're looking into multi-step refactoring because of a large code base or scale problems, these are the types of things that you're going to lose access to first. I will go into examples, but first, any questions? We good?
I fail to see how this remove of an API should be atomic, because like if you have many commits coming in, then it's hard to.
So it is remove an unused API, barring race conditions on the version on your repo, right? Like and this actually gets. It is a great question. This gets actually to one of the things that I think is really important, which is aiming for green CI 100% of the time is like aiming for 100% uptime, right? And if you've read any of the like SRE DevOps principles in the last 5 years, right? You're not aiming for 100%. You're aiming for some number of 9s, right? You're always going to have race conditions in your version control unless you actually have a world where you lock the repo from the point that you kicked off the tests until the point that your tests were green and then you committed, right? And that is really a bad scaling problem, right, as your organization gets larger. I saw Frank and then Bryce.
Would that be a use case for marking the API deprecated and then letting that sit out there for a while for trying to remove it?
Frank's question is, does it help to mark the API deprecated and let that sit out there? In our experience, all of this really only works if you have someone actually powering through stuff. Stuff doesn't get better on its own, no matter how much static analysis or documentation, like no matter what warnings you surface, you'll only get a small fraction of that job done. Whereas when you assign experts, those jobs get done. Marking it deprecated might warn people a little bit, but again, the goal is not 100% uptime. The goal is not 100% green CI. If you broke someone's build by they missed the commit window by 5 minutes, 10 minutes, it doesn't really matter that much, right? It's fresh in their mind. They'd be like, oh, look, you did that. And then they go fix it, or they talk to you and you fix it for them, right? Like, it's fine. None of this is theoretically sound, right? Because when it boils down to it, nothing is theoretically sound. Right? Like, you cannot make any change whatsoever and prove that it isn't going to break somebody. You cannot add things, you cannot remove things, you cannot change comments, you cannot, nothing. And for more on that, put a couple beers in me and we'll talk. Bryce.
So we're not at the same scale as you, but I think we avoid this race condition problem. And here's how we do it. If you have a change and I have a change and they're conflicting, and we enforce pre-commit testing before anything is landed.
Yeah.
So you kick off your pre-commit CI, and when I go and kick off my pre-commit CI, the system will recognize that our changes are conflicting, and it will say, I'm not going to start, it's not going to start pre-commit CI for my testing until yours passes, and then it'll rebase mine on top of yours.
Yeah.
So that
yeah. So for Bryce's suggestion was, in their world, they recognize when two pre-commit CI checks are conflicting, which is actually the root of why I'm air quoting that, right? Oh, the same file was edited is a really gross, like oversimplification of these two changes are actually compatible.
It's usually, we do it on file edited, we also do it on if we kicked off the same components for built-in tests.
Yeah, I mean, like, there are things that you can do to try to mitigate, but like, the problem still is there in theory. You can mitigate, but it's always there in theory. So anyway, going into examples for what we mean, like, concretely when we're talking about multi-step refactoring, I'm going to talk about renaming a type. So we had this problem when we wanted to change from our homegrown string piece. This was the class that actually inspired std string view. And we needed to rename that to Abseil string view because we didn't skip straight to 17. So there was a time when we needed string view to exist in the code base, but we didn't want it to be, but we needed it to have its own name. Did you have a hand up or are you just sitting? Okay, great. So we want old NS string piece to become ABSL string view. How do you do that? Because of scale, we can't just use rename a type and commit one giant commit that would have touched, I don't know, tens or hundreds of thousands of files, something ridiculous. So obviously, we just open up ABSL and add a class string view and then copy the guts of string piece, right? This clearly works, right? Right? This clearly works. Right? Raise your hand when you have come up with one way that this doesn't work. Yeah, some hands are starting to go up. I could probably get you, I don't know, 5. This is not even close. In practice, there are so many ways that that goes poorly, and a whole lot of things that we thought might work until someone pointed out, well, that's not how the language works, or until we ran into some surprising thing, thankfully, because of CI results. So, in particular, I said earlier, multi-step refactoring goes better when there's not a sequencing between individual changes, right? So imagine that foo.h and bar.cc are in maybe far disparate parts of the code base, okay? If one change lands to change foo's signature from string piece to string view, right, then bar stops building. If bar has the same change applied before foo, then bar stops building as well, right? Because these are two different types, regardless of the fact that we know that the body of the thing is the same, right? We know that, the compiler doesn't know that, right? And so inherently, because of even something as simple as like a function call here, these two files could only be changed in the two-type form, in the simple two-type form, if we made sure to change those in the same commit. And now we're starting to sequence things. When you start building a whole graph of like, oh, and this has to happen before this, and this has to happen before that, and blah, 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 you're gonna spend all of your time doing graph processing and none of your time doing refactoring. And so we just don't like this approach. We've never found that to actually work. So we're not gonna do that. So maybe what we do is we write conversions one way or the other, right? Maybe string view converts to string piece. Right? In which case, if I commit that change, right, I add a conversion from string view to string piece, then bar still builds. So hooray, we fixed this. Obviously not, right? Imagine user code is convertible from their own class into string piece, right? Remember the rules on conversions, right? You can only do one user-defined implicit conversion at a time, right? So if users are using this at all, we can't rely on having that, like, I have the right to do one conversion, right? Refactoring means you have the right to do 0 conversions because the users get the right to do the conversions, right? So this doesn't work either. And on top of that, those overload sets are gonna get messy if we decide that, well, maybe the right way to do this is to find everyone that was convertible to the old thing and make it convertible to both things, right? Then we don't have to pick. Well, except we have overload sets and now it's ambiguous, right? It's not clear which of those you wanted to convert to, even though we know under the rules of good overload set design that it doesn't actually matter which one you converted to, and like, I could go on. So having two classes, no matter how clever you get about which converts to which and which way you look at this, having two separate classes there doesn't actually work. But no one actually said that we needed to have two classes, two distinct types. What we said is we needed to change the name of a type. What if there was a way for a type to have two different names? Of course there is. We add an alias. Right? So instead, we shift all of the code inside the new namespace and we leave behind this old alias, or this alias for the old name, right? Much, much better, right? There's only one type. Both names work. This should be fine, right? Raise your hand when you see a way that this breaks, right? Okay, so first off, there's forward declarations. Every smart user that forward declared the old class in order to avoid some compile time has broken your refactoring. You have broken their build. You are going to fight. I don't know. Pick which way you want to phrase that, right? But you're going to have a thing happen here, right? And the really frustrating part is if you are working in a code base of like, I don't know, tens of files, forward declarations are a very reasonable way to optimize your micro benchmarks on build times, right? Cute, adorable, and I forgot how to count that low, right? We have millions. The last quoted number was, I don't know, 200 million lines of C++ code. I don't even know how many files, right? And the problem when you actually scale up like this is that forward declarations didn't help in the first place because forward declarations in a modern parallel build are only going to affect your build in any way, shape, or form if the longest latency translation unit can be written in such a way that it actually only needs the forward declaration, doesn't need the body of the thing, and if every single user, every single header in that chain reliably only uses the forward declaration. If a single one of them does the pound include, then you're going to add the extra 10 microseconds to load in that header, right? If any single person in your code base, in your organization, gets it wrong, then you lose the optimization, right? And on top of that, you've just made this code very brittle in the face of refactoring. So there is one way that this actually works okay, and that is, very specifically, exactly what the standard does. I'm not sure if the standard does this out of forethought or just by accident, right? But what we have done with iOS forward is actually perfect, right? If the owners of the types in question believe you that the header in question is expensive, then they can volunteer to provide you a forward header that is just forward declarations in the same location, side by side with the original header, right? And maintain those together so that the forward declaration can be updated to be an alias during this refactoring step, right? You win to the extent that forward declarations matter, and the maintainers are not hampered. Right.
And I think it's, at least from my experience, it's much more common to see forward declarations to avoid like circular dependencies than as a performance optimization.
Right, and for avoiding circular dependencies, totally fine, right? Forward declarations are like go-to, they're not morally wrong, you just need to know what you're doing, right? But the number of people that I've had come up to me and are like, forward declarations are great for fixing my build time. I'm like, nah, man, right? Step one, go get a modern, parallelizable, cacheable, reliable build system, then we can talk about it, right? But if you're not actually parallelizing your build, this is nothing, right? So anyway, that's my rant about forward declarations. This is gonna be a ranty day. But there is a deeper, scarier, more horrifying thing that is going to break with the way that I have proposed adding these aliases, which is the eldritch horror of librarians, ADL. This code worked fine until I changed my type to live in a different namespace. I have to now re-summarize what ADL is for everybody. And I've talked about this a little bit in some of my talks in the last couple of years, but it bears repeating because for most people it is surprising. So when I have a unqualified function call, like the call to log to stood out, we are going to do lookup to figure out what function is actually being called. And that lookup starts in the current scope and moves out. So I'm going to look, is there a log to stood out in F, or in user, or in the global namespace? But also, and here's where it gets interesting, I'm going to look in the namespaces of the arguments to that function call, right? And it has to be the arguments to that function call and not the namespaces of the parameters, because we don't know what that function call actually is yet. We don't have a declaration of the function to take the related namespaces, right? We have no idea which function we're actually calling. But we do know the namespaces of the arguments. So I assume in this example, the function that returns, or the function some string piece returns a string piece. And the namespace for string piece is oldns. And oldns happens to also have a function called log to stood out. And so this code works. According to some of our recent statistical checks, something on the order of 10 to 20% of unqualified function calls in the wild are actually depending on ADL, right? So if you just start changing the namespaces of types, right, your code base is going to explode in new and surprising and very frustrating ways. So, hooray! So the change of moving string view, or moving the body of the class into ABSL, aliases are not types and don't have associated namespaces, which is a design choice on its own. Yeah, it's in the standard. Man, you sit on this committee. Don't you know it by heart? I'm super joking. So what we actually wind up doing is you leave the type in its old home, you add the alias in the new location, and then you blast through the code base over and over again to find all of the spellings of string piece or oldns string piece and change them to ABSL string view. And at the same time, you find all of the unqualified function calls that are dependent on the namespace oldns via ADL, and you qualify them, and I can give you statistical argument that 0 people actually care about that. Nobody has ever complained, you added 6 characters to that function call, right? I was intentionally depending on it. No, they weren't. Like, they just wrote it, it happened to build, they didn't care, right? This is fine, you just go update everyone's code. So you go do that, and the point that you have nobody actually depending on ADL, then you can swap those, right? The class lives in the better namespace. And at the point where you have no spellings of string piece, then you delete the old alias, right? And it does not matter how long this takes, right? This operation can be paused at any point. People can go on vacation, right? It will backslide a little bit as people commit old code, do things out of habit, all of that stuff, right? But fundamentally, the code base from every individual developer's perspective continues to work just fine at every point, right? And that is the point of multi-step refactoring approaches. Questions? Ghosts. Yes, Frank.
Have you encountered anyone trying to specialize in string piece?
Our version was not a template. As it turns out, we have relatively well-behaved users that tend not to specialize things that they're not meant to. And when they do, then we go undo that first before we start some of these operations. Like, there's usually a setup and a cleanup phase for a lot of these things. Oh, that doesn't matter. It's an alias.
Yes. No, that's just another argument against like the 2 types.
Yes. No, the 2 types thing does not work at all. It's like, not even close, right? You have to do this with an alias. Okay?
So once you're at the position when you can swap, you are still breaking ABI.
Oh, yeah. If you need ABI, you can't change anything, right? You should go to a different room. Like, ABI is totally off the table for all of this, right? Like, you're going to change names, you're going to change manglings, all sorts of things. Like, it's all different. Like, if you need binary compatibility, none of this is, I believe none of this is available. Like, I've certainly not thought about it.
You could still just leave string piece as a copy and make Abseil as a proper class.
You could maybe leave it as a copy.
Like, instead of it being an alias.
Yeah, but
Like, you basically change it to be a proper type once you're switching.
right. I would recommend that if
Symbols, but you have no more spelling, so it's okay.
right. If you have ABI problems, I don't know, man. Like, I am genuinely not sure that any of this is worth thinking about if you're actually ABI stable. Like, so. Some things that do go wrong with this. We're only actually fixing up the type system. So parameters and local variables that are named SP as a shortening of string piece are not going to get updated to be SV. Functions that talk about returning or converting to string piece in their text are not going to be updated. Documentation, comments, things like that are not going to be updated. In theory, a lot of these are doable in theory. We've just never really prioritized like digging down to do that. They tend to sort of resolve themselves on their own, but it does leave behind, you know, there's a trace. You'll usually have a archaeological layer of like, oh wait, what? But then like it looks a little hinky when you're done as a result. So, Victor.
So do you have some sort of code jam in your code base that may use the string piece as a string in some C++ code? Like,
Oh, code generators? Yes, code generators are a special hell. Because, yeah, the AST matcher, like compiler-based tool refactorings will track down all of the places you're calling this stuff, right? And then almost universally, some of the last round of stuff is go track down all of the code generators that are emitting references to that code that's being dynamically built as a step in your build system. And then this is why people on my team wind up with weird amounts of, yep, I have committed 700 lines of Java and 42 lines of Go, right? Because like some weirdo wrote a Java program that emits a Python program that generates C++ code. Like, we've seen it all, man. Any other questions? Frank?
How do you distinguish between generated files and not generated files when trying to apply a limited piece of like this refactor?
As a human, there's generally comments at the top of the generated files that say, this was generated, do not edit. All of the tools don't care. They just blast through there and like edit them and then get squashed and then blast through there and edit them again and then get squashed. And then eventually a human notices and is like, oh, okay, let's not do that. And they go through and fix it manually. But like, there are manual steps in all of this, yeah. At least at sufficiently large scale, there's manual steps. Fundamentally, this trick of finding an alias is really valuable, and it underpins at least all of the ways that you might rename things. So for renaming a type, we use these sorts of aliases. For renaming class templates, the same roughly applies. You use template aliases. For concepts, we think this works. This is not an alias. This is introducing a new concept, and both concepts subsume one another. So in the concept algebra, they are equivalent. Equal? Equivalent. Equivalent.
They don't have the same name.
Right, they don't have the same name, but they are equivalent. So they are substitutable and all of those things. But that is highly untested and hypothetical, right? Nobody has actually written millions of lines of concepts, much less refactored them in anger. So come back in a couple years and we'll see. But more surprising than that is you cannot rename a function. There is not actually a good mechanism for this. You can get close-ish using something like that, except the resulting thing, new name, is a function object, not a function. And so that will fail if there's overload sets anywhere or ADL was actually desired, among other things. And we could do this with an inline function. That'll get you similarly part of the way there. But that's kind of manual and fairly bespoke, and you trusting the inliner to do its job properly. It will still fail for ADL reasons. And if for some horrible reason you have code that is comparing the value of function pointers, these were certainly not going to compare equal, right? We just don't actually have a mechanism to alias or rename a function. If you just want to change the namespace of a function, this is total side note, using declarations do work in the expected fashion. But if you actually want to change the name, you are out of luck. Weird language, huh? Anyway, this sort of summarizes the very high-level strategy that underpins most multi-step refactoring tasks, which is that you want to find a way to express the pre- and post-refactoring state, whether that is syntactic or semantic, in a way that they can coexist. Sometimes that means you might need to do a pre-step to rename everything away, or leave some syntactic token to say, I am specifically opting into the old behavior, right? And then, once the old behavior is free, then you can change the old behavior because it's not, or you can change the default because it's no longer used or depended upon anywhere. You're going to wind up converting all of the individual calls, the rename from string piece to string view, and then hopefully you can clean things up. You delete the old alias. Okay? We'll go through a more semantic example, changing the default precision for stircat. When it was first introduced, stircat produced a full precision representation of whatever the value of the double was, and it turns out that is fairly computationally expensive because it's just as much work to format the least significant bits as it is to format the most significant bits. And most of the time, people actually only wanted a few bits of, or a few decimal digits. It was the wrong default, we think. So how do you change the behavior safely? What we did is blew through the code base to add a call to legacy precision, which did nothing, wrapping every double that was being passed to stircat. Okay? Now, at the point that nothing is being passed to stircat that is a double except legacy precision, you can change the value of legacy precision and double in one small localized change safely. Right? You see that? Everyone make sense? Yeah. And so, one single change changes the internal behavior of stircat and the signature of legacy precision. It's actually not string, it's some internal stircat alpha num thing, but whatever. In practice, we applied some heuristics in doing this so that we could see where the legacy precision behavior was actually wanted or when we could prove that they didn't want the legacy precision behavior, because we wanted to leave it out as often as possible, because we'd rather not increase the amount of crufty mess that we leave behind every time we run this sort of change. And I am simplifying. The code base doesn't stop moving just because we started doing the operation. New calls to stircat on double are introduced constantly, so we have to manage what we call backsliding. For smaller interfaces, we don't really worry about that too much because the tooling involved, I think we set a new record of, I don't know, some number of millions of lines of code were refactored in a week just recently. So like, if it's a thing that like 4 new uses of this function cropped up in a given week, like we're like, whatever, the tools will blow through it. Right? But if it's actually a meaningful amount and it's backsliding fairly quickly, then we might start tagging things deprecated for some minor amount of help on that, or introducing a clang tidy check to like immediately notify people if it's more complicated. But those are usually the sort of rarer cases. And of course, there's the certainty that if we leave this going for long enough and have enough scale going on, someone is going to misuse the function legacy precision for some other purpose. And we're going to wind up broken, their code will wind up broken when we make this change because Hiram's law always wins. But in the end, you wind up with a recipe that looks sort of like this. Everyone see that? Everyone make some sense? Yeah? No questions? Cool. So this is sort of like exemplars of multi-step refactoring. We don't do this for every change. Obviously, right? Most things that you're used to in development don't require this. Most changes that you might be making, most additions, most feature additions, right? Most new code, right? These things don't require that. They don't, right? We want it to be cheap and safe, right? You can, of course, you can just add a function, right? Add a function, that's fine. Add a new class or a new class template, that's fine. Add a new member to a class, that's fine. Add a new entry to an overload set, that's fine. Right? And making sure that those stay fine actually sort of underpins some of Google's like reticence to approve changes in language for C++ in particular, right? Add a member to a class could become a build break or a behavior change if we went down the path of unified function call syntax, right? Like, please don't make that. Like, please don't make me have to run CI for everything in the world just because I added a function to a class. I similarly am kind of against the changes in std optional for C++20 that add more like monadic chaining, specifically because they mean that we start trafficking in function pointers more. And function pointers work fine if that function is just a function. If that function becomes an overload set, that's a build break for every user that was monadically handling that function, right? And that's unfortunate. We don't love that, right? We really want the language to move away from referring to a function by name is taking a pointer to that function to operating on overloads. Yes, Bryce? Yes. Do not take the address of things that you do not own is like way, way high on our list. And you can't use the monadic optional features elegantly. Like there's no point to them whatsoever if you're gonna wrap it through a lambda or something, right?
But my point is just you picked on optional in particular there, but this is not a problem specific to optional.
It is not a problem specific to optional, but it is far more common, right? Like you could easily imagine a world where Optional gets used like that regularly, far more regularly than we have callbacks or functors in the algorithms library right now.
But does that mean that you have the same problem with senders and receivers and networking, which also relies on heavily on callbacks?
Yep.
Okay. Just
Right.
making sure.
But I don't think that there's that many functions that you don't own that are going to become the target of that callback.
Okay.
Right? Make sense?
Yep.
And of course, it's not just additions that should be cheap. You should be able to weaken preconditions, define implementation, define things, stabilize what's random, all of this stuff, right? There are a bunch of things that can clearly be done cheaply and should continue to be done cheaply. I am merely talking about when the cheap options don't suffice. Here's a more expensive way to get the job done.
Hammonds law, how can you possibly be lost to?
Sometimes it's cheap. You do occasionally get away with it. So, oops, sorry. So we will sort of step through the hierarchy, right? Starting at functions and look at the more and more abstract design structures and look at what can we actually change and how expensive is it. So can we change functions? Ghosts. The things that I know are small, the things that I know are cheap. Right? You can weaken preconditions to allow that function to be called in more contexts than it used to be. You can strengthen postconditions so that it produces a smaller range of outputs than it used to be. And if you sit down and you think about the algebra of like functions and types and composability, right? Those should make sense to you. Okay? Things that are expensive that you can do if you're willing to do a multi-step refactoring to like dynamically or statically demonstrate that those behaviors are no longer relied upon are the opposite. Right? You can strengthen preconditions to prevent some previously valid calls if you can statically or dynamically track down all of the places that was depending on that behavior and move them away. You can weaken postconditions in the same fashion. Right? Does that make some sense? Can we change the return types? Now we're not talking about behavior, but we're talking about syntax, the type signature of your function. In the case of changing a function that's returning void, probably yes. The only thing I've ever seen go wrong here is when someone has written that, right? And that does not happen often enough for me to care. And I am not the only one that doesn't care. There is precedent for the standard not caring because we did it in C++ 17, and we did it again last week in C++ 20. We did it in 17 for vector and placeback, and we did it in 20 for some of the algorithms, although I guess it's not a change because they hadn't shipped yet. Some of the ranges algorithms changed from returning void to returning count, something. But in any case, yes, you will almost certainly get away with this, unless your users are writing some very weird code. On the other hand, widening numerics, for instance, not so much, because the output of one function tends to be the input of another function. Right? So if I was to change this int to an int 64, this is going to be a break because we have now narrowed. It would also be a break if you have narrowing conversions turned on in your compiler just for locally assigning the variable. Right? So this doesn't work in a single step. I can't just locally change that function foo to returning a different thing. What do we actually do? I think that this is the most reasonable recipe for that, which is to take the old function and all of the users of the old function and move them somewhere else, then reintroduce a new function of the old name, right, just foo, with the behavior that you want, and then move back everyone that is safe to do. You're going to be relying on heavily beating up your CI system to see what is both statically and dynamically safe to do, right? But you can pull this off. You're going to hit every user of this function twice. That's unfortunate, right? But if you really, really cared, there is a way to do it. I tend not to do these things that you have to hit people twice, except in extreme circumstances. How about the other way around? If we wanted to go from long or int64 back down to int, is this safe, right? If it's not safe to widen, is it safe to narrow? No, for a whole bunch of different reasons. For one, The format string checker is going to hurt you. In fact, this hurts so hard. This is good. There is a type def in our code base from like 15 years ago where we really just wanted to express that on our platform, we need an integer that is 64 bits. So there's a type def of, if you say int 64, that means long, long. Right? In the intervening period, the language introduced int 64t. Int 64t is a different type than long, long. And we would like very much to unify those, right? We would like very much to spell them the same way, right? But can't just do that simply, right? First, we're gonna have to actually make int 64 into a type def, or into an alias for int 64t. And right now, well, a couple years ago, there were about 60,000 instances of the format string checker in our way. And there's not a really good, actually like portable way to express that. So instead, we fixed up and released Abseil stir format because releasing a new, very complicated C++ API was a lot cheaper than just fighting through that nonsense. That gives you a sense of the scale of how frustrating this problem can be. And you hope that it's just the format string checker getting you, because it would actually be UB if you got this wrong and the format string checker didn't catch you. So, bleh. Even if you have no printfs, even if you are a IO streams only shop, you still get deduction failure, right? If some long is returning a long, and then it suddenly becomes returning, or the long stays long and foo changes to int, now we can't deduce, I don't know what you meant. Thanks, stdmin, for being very helpful. So then you have to go through and explicitly specify which type you want that min to be computed in. The long tail here is messy and ugly. Yes, Frank?
What would happen if you wrap every invocation of the function with a cast back to the type that it has?
I mean, you could, Frank's suggestion was find every invocation of the function and just cast it back to the old type. You could absolutely do that. I don't like to do that because you can only do that a certain number of times before your code base looks like line noise, right? Right? Like the rule that I try to hold all of my people to is if the end state of your refactoring doesn't look like a human did this, then no, you can't do that, try again, right? And unfortunately, that means we're gonna do the robust thing all the way or we're just not gonna do it because technically you could get away with that, but you wouldn't wanna do it very often. Does that make sense?
Thinking of this like mostly conversion out to the call site and then reason about call sites to get rid of the cast somehow.
Maybe?
Maybe you may. So.
I mean, yes, the maybe, it's definitely a maybe. Like, I believe that we are pioneering here. I cannot promise that this is the one true way to do any of this. I can express what we have found works. I'm hesitant about that approach, but I cannot say with any authority that it's the wrong direction, right? If you have a secondary pass to clean up those casts afterwards, that might be really interesting, but that's outside of the realm of our experience. So yeah, maybe. Other questions? So I'm going to summarize this with changing function signatures, usually hard, right? Changing the signature of a function is going to break something. As a basic refactoring, right? Something that we could easily talk about, it is actually a fairly expensive one. And that's true even in the good case where people are just calling the function, right? If there are function pointers and forward declarations in place, it's going to be more expensive and annoying. Okay, functions. Types. Start with something easy and compatible. Can we change usage of compatible types? Can I change this unordered map to a node hash map? Right? I might say to myself, oh, I happen to know that node hash map is 30 or 40 times more efficient than unordered map. Let's do the more efficient thing, right? Can I make that change? Of course not. One, this is expensive because of Hiram's law, and people that have written tests like this or production code that is morally like this, right? This test is going to fail because we're asserting that when we iterate through the hash map, we're going to get back the values in that particular order, right? If I changed elements R to unordered elements R, then the test will pass because I'm not expressing you have to see these values in this order. I'm expressing you have to see these values in any order, right? This is actually what people usually tend to mean, but not what they tend to write in the tests. And God forbid, there are groups that have dependence on the iteration order of their maps serialized into your databases, and you're gonna have a bad time, okay? For more stories on that particular topic, go see my friend Matt Kulakundis' talk on hash tables from CPPCon a month ago. It is a very funny, very detailed talk. It was really great. It's one of my favorites. This is also expensive because vocabulary types form dependency networks that are both expansive and expensive. Because it is reasonably likely that it's not just a declaration in F, it's a declaration in F and I'm passing it to something perhaps, right? In which case I can't just change where I'm declaring this variable in F, I have to also change G. And of course, this might not be the only thing that is passed to G, so I have to also find everything else that is passed to G. And of the set of things that are passed to G, they might not be passed only to G, they might be passed to other functions as well, right? And so on and so forth, iteratively, right? You have these dependency chains of declarations and instantiations that may actually span your entire code base. We are terrified of making changes to amongst vocabulary types because it could be arbitrarily expensive and very graph problem-y. And I say that. And then, again, my friend Matt Kulakundis came to me when we were introducing the Abseil Swiss table types. And he says, so it occurs to me, what we are trying to do here is save a big massive pile of CPU and a big massive pile of RAM. And what we aren't trying to do is replace every single usage of unordered map. What we're trying to do is reduce the aggregate cost of having used a bad map type. And so it doesn't matter if we get all of it, it just matters that we get a lot of it. So his proposal was, we're going to run the same normal unsequenced changes and see which ones of them can actually be committed. And just blast through the code base, wasting so much CI power. Like, oh, that change applies cleanly now, that build is not broken, CI still passes, commit it, right? And we actually got, I don't know, something like more than 50% by spelling replacement on the map types. I think we did make some locally targeted changes to like add an overload on G for the new map type instead, but relatively minimal overall work. And that turned out to help us immensely, but vocabulary types are expensive. Actually, another ranty sidebar, vocabulary types. I say this fairly regularly. I should write down like Titus's design rules somewhere. Don't introduce new vocabulary types lightly, because please consider overload sets, the care and feeding thereof. Please consider template specializations. Right? If someone has specialized on the old map type or string versus string 2, they won't have that specialization when you introduce string 2 or the new map type. User-defined conversions get weird and sometimes impossible, especially in the face of overload sets. The runtime cost for your ecosystem of converting back and forth between string and fancy string or unordered map and hash map, right? Having multiple things that are the same platonic idea of a like underlying type being the common vocabulary and fighting that tension costs both, like costs in developer sanity, costs in runtime performance, costs in all sorts of ways. Our C++ team has run into this a few times. It's not language specific. The Java team, if you find anyone that has ever worked on Guava, ask them to tell you how they feel about optional. Because Guava in Java had a very nice optional type, and then they got that standardized, and the API changed a bit, and now there are 2 canonical optional types in our code base, and they don't convert, because that's not how Java works, and It's horrible. And like the spellings are just slightly different on the API, so it drives every developer absolutely batty. It's no good. It's super bad. So anyway, vocabulary types, don't do that lightly. So stepping back, can we change usage of compatible types? Kinda. It's tricky. The difficulty scales with how common, how vocabulary your thing is. Right? Vocabulary types especially are more expressive but harder to change. We can't change the behavior of a type itself lightly either. Changing behavior, semantics, class invariants, all of those things are harder than changing a function. Part of that is explicitly because you lose local reasoning again, right? Changing the input or output of a local calculation within the body of a function, say, clearly can be done with only local reasoning, right? You can like refactor the internals of your function, that's fine. Changing the input or output of something that is stored in a type and then passed around requires a whole lot more proof, a whole lot more reasoning, a whole lot more information, because that object is then going to be passed into other APIs used at other times in your program. And it's a lot harder to prove that that change is going to be safe. Think of it this way. You can't weaken preconditions on a function without affecting anyone. Or sorry, you can weaken preconditions on a function without affecting people, but you can't weaken postconditions. One of the most common, easily understood bits of API for a type, setters and getters, right? So you could say like, oh, this value has to be positive, right? And you can have that as a precondition on your setter. You could weaken the precondition on the setter so long as you then take the absolute value of it, right? Because you can't weaken the precondition on the getter, or postcondition on the getter, right? Does that make sense? Right? Otherwise, you're going to break people that were depending on the invariant of the type. Classes are about invariants and also object lifetimes. Changing the invariants requires more than just knowing that it's currently okay to change the invariant for a single object. It's about changing the invariant for every object of a type and across every execution path in your program or your code base. That is obviously harder to prove. Make some sense? More than types. We change virtual interfaces. Say, we used to only operate on quadrilaterals, and now we want to operate on circles. So we want to change int to double. Can it be done? It can be done, but I think that's the easiest recipe for it. And that's going to hit all derived classes several times, maybe 2 or 3, all users at least twice. It's subtle and tricky. And this is actually my favorite surprise in here. When you're removing the old name for the thing, you absolutely have to start at the bottom of the class hierarchy and remove those because of the override keyword, right? Because if you remove it from a parent class, then you might not be an override anymore, right? So like, surprise, that just got more complicated. It's all doable, but this is meaningfully harder than changing the return type on a function. Okay. Function templates. It's mostly the same as changing a function. We can weaken preconditions, strengthen postconditions, but what if there are specializations?
Then you are evil.
Like, I mean, you could get some yelling out and like tell your users not to do that, but like, ooh, that's going to be interesting. If you've disobeyed all of the good guidance and written weakly constrained or unconstrained function templates, then effectively all of the implementation details have also become your interface. Who knows what crazy, what unusual user-defined types have been passed to your function template, to your unconstrained function template, right? If you implemented it so that it only used operator less, and you're like, this needs to be a numeric value. Let me tell you, there are going to be types that have been rinsed through that have an operator less and nothing else, right? Because users are very clever, and clever is not a good word. Even if your function template works for the types that you expected, some users will have been clever and they'll be broken by any implementation change. This brings us now to concepts. Can we change concepts? And I will remind everybody, in a single step, you can do whatever you want, right? If you have perfect visibility to everyone that is using your thing, you can do whatever you want. Delete the code base is a single step refactoring, right? Find replace for everything of that name is a single step refactoring, right? But if the scale of it is too large or the visibility is imperfect, I think the answer is just no. Anything that would require, like, you're gonna have to do a very expensive, complicated multi-step refactoring that we don't understand yet. We can rename them, but I don't know how to do anything more substantive yet. There may be some cases, but it's a lot of work and it's gonna leave a mess. So we'll start here. Weakening a concept is out of the question. So this is not high fidelity, but representative of a change that's was being made late in C++ 20. We wanted to change input iterator and also output iterator so that instead of requiring copyable, it only requires movable. Remember, for input and output iterators, if you made a copy of them and you read from one of the copies, the other one is forbidden. Logically, what we actually wanted there was the machinery to express these only have to be movable, right? But if we shipped the concept and there was code that was, say, copying it, we can't take away the ability to copy it, right? You can't weaken a concept because it's being used in that sense. And strengthening is also out of the question because of the other ways that you can use it, right? So for instance, if I had a really dumb addable that is just checking syntactically that operator plus works, I can't later add either a syntactic or a semantic requirement that addable implies commutative, because there are things that have an operator plus that are not commutative, like std string. Okay? This existing code would be broken by adding additional requirements to the concept. So it's going to be an intensive multi-step refactoring at best, if it is possible at all, to make sure that everything in the code base doesn't actually impinge and is actually compatible with whatever change you're trying to make. And when we're all the way up in the meta machinery of concepts, I have no idea how to do that. Like, your AST is not going to match on that sort of stuff, as far as I can tell. Frank?
Would it be an idea to split a component? So you make a copy of it, and then every function that requires this
Yes.
gets the one type, and every type that tries to implement it gets the other one, and it's like steady to make sure this implements whatever concept. Try to change it independently.
So Frank is pointing out that part of the issue is that we have functions implemented in terms of these, but also types that are trying to meet those requirements. And if we separated those so that it was two separate names, then we might have more room to maneuver. And that doesn't sound wrong. But again, like, no one has actually done any of this in anger. So like, we're gonna eventually stumble into this. I'm just trying to, like, this is as far as my flashlight goes. Like, if anyone ventures into the dark before me, like, warning, this is what I know. Interestingly, this is fresh as of last week, I believe that you can change the expression or implementation of a concept so long as you aren't weakening or strengthening it, so long as the set of types that counts as matching the concept doesn't change. So for instance, if we want to pull out a new sub-concept from an existing one, right? We had addable that was both operator plus and commutative, for instance. I could pull out operator plusable and change the implementation of addable to be, I subsume operator plusable, and I also add commutative. And that refactoring doesn't change which types count, and so I think you can do that safely. So long as you aren't changing the actual requirements, you're just changing how the requirements are expressed. Concepts are not unique in all of this. You see exactly the same things, and maybe this is even an easier way to understand it, in type erasure for things like std function or std_any. Type erased types are, I've said before, very much the dynamic runtime library version of concepts. In fact, you can see it pretty easily here, I think. You can't add an API to a type erase type. Like, you can't add toString to std function without having toString in every function object that is ever constructed to, like, underneath std function, right? So if you first did the ridiculous multi-step thing to, like, add a toString to every lambda and every, like, everything everywhere that was ever called with std function, then you could change the requirements on or the API of std function to have a toString. But you're not going to do that, right? Similarly, you can't remove stuff from the typed erased interface of std function, right? You can't remove the call operator because things that are operating on std function are calling it, right? This is exactly the same duality that we have with concepts. And that sort of describes the general problem, right? If a design structure like any of these things can be used as both constraint and interface, then changes to that are going to be hard. You can't weaken or strengthen or extend it. And so in the end, I wind up with the belief that the more expressive the design structure, the more expressive the new language feature, the higher the refactoring cost. And I find that really interesting because it's the opposite of how all this started, right? We moved away from pile of code to structured programming, and the addition of structure gave us new constraints on how to write code and actually made things easier to change. But as we've moved to higher level structures, that's less and less true, specifically because we are walking back from we can change with local reasoning. Types, especially vocabulary types, templates, concepts, these all provide more expressive ways of saying these are all related, these are all the same, without overly constraining locally and with being much less code to write. That's nice. But it comes at the expense of preventing us from performing local reasoning. Now that reasoning is spread over all of the places that that structure might be used. You can't weaken or strengthen a concept specifically because there is no small local domain that you can check when making the change. We've done away with local reasoning and moved to whole program or whole code-based reasoning again. Templates and virtual functions are more expensive to change than their simpler function and concrete class relatives. Even the structures that are arguably zero-cost abstractions in terms of runtime have meaningful costs elsewhere. Recap. We've seen a few things. We looked at the difference between traditional definitions of refactoring, the Fowler refactorings, things you would see in your IDE, and what I'm terming multi-step refactoring. This covers a wider scope of changes, is applicable in more scenarios, but is certainly more labor-intensive. Another way of looking at it is that these multi-step methods are what we rely upon to make changes that others would say is a breaking change. I still hate the term breaking change because, in my experience, everything you do, no matter how innocuous, can break someone. We've seen that changes to function semantics are cheap in some forms, weakening preconditions. But in a strongly typed language like C++, changing the type signature of a function isn't necessarily safe. It's going to be a little expensive. Even just widening an output type is a potentially breaking change because, even if it isn't across the whole program, types are both inputs and outputs, right? And so you have these local links that break the property of local reasoning. In the sense that classes are just bundles of data with functions to access them, all of the same rules apply. They tie interfaces together in more complex ways, and they add new time concerns to the semantics. We're spreading time across the lifetime of an object. Data that is held in an object may be involved in preconditions and postconditions for numerous interfaces across a project, and that's obviously going to be harder to reason about if you're trying to change those invariants. Classes help us encapsulate. That is very valuable, but they are also harder to refactor than just a function. Templates help us generalize even further and give us more expressive power, but we pay for that with higher difficulty and more ways for things to go wrong. Even simple things like refactoring a function template get a whole lot more difficult in the face of specialization or poorly defined user types, things like that. Concepts are the newest addition to this hierarchy, and nobody has any real experience maintaining them, right? We have a few people that have written them enough to understand how that all works, and that's great. But nobody has any experience maintaining them or trying to change them. And at present, it doesn't look like concepts are amenable to change in scary ways. We can neither strengthen nor weaken them without potentially breaking existing code unless you have perfect visibility into all of the users of that code. Multi-step methods may mitigate that, but I encourage authors of C++20 libraries to be very, very careful about publishing new concepts. You may be stuck, or just have to break all of your users. Like, your mileage may vary. I will take a second here to plug something that's vaguely related that I'm very excited about. When you think about this, none of this discussion of refactoring really matters until we start thinking about maintaining things over time, the need for change over time. Right? Your architecture has changed, your business requirements have changed, the security libraries that you're depending on have bugs, right? You need to deploy a new update, et cetera, right? Change is inevitable over time. I've said in other talks, software engineering is the integral of programming over time, different dimensions, different dimensionality, different units on the problem. It's a wholly different thing to talk about how to write some code than it is to talk about how to write some code and then maintain it for years or decades. And I've spent a lot of time refactoring and a lot of time thinking about how time impacts all of this stuff, and that motivates a lot of this talk. So if you want my thoughts and the thoughts of many other Googlers on software engineering and especially how time impacts your development model, go pre-order this book. I think you'll find it worth your while. And with that, questions? Bryce. All righty, everyone?
Earlier that we could take a concept and take part of the requirements stack concept and split it off into another
Yes.
subconcept. I do not believe this works because if I've got a function that takes that original concept
Mm-hmm.
and I add an overload that takes the new concept.
Ah.
Yeah.
So
That's going to, if I just add the new concept without, like the new subconcept, without changing the old
right.
Concept to use the new subconcept,
Yep.
then it's ambiguous if I add an overload that takes the subcontext.
Right. So Bryce's point is it's not necessarily safe in general to pull out the new subconcept and change the implementation there. My response to that, because if you introduced the new subconcept separately from making one subsume the other, an overload set on those two concepts would become ambiguous. Not 100% sure that's true because one is more specialized than the other. And two, specifically what I said was you can pull it out of here. You don't think you can find, oh, it happens to be the case that this other concept does everything I need. Let's just add that. Because I do agree that might change things, but I'm not 100% like, nobody's done this in anger. I think it is vaguely possible that you could break overload sets or make things ambiguous, but I don't know for sure.
My point is that like
If you don't give anyone the chance to write code in terms of the new concept before the new concept is part of the subsumption of the old concept, then you can't have that race.
Yeah. The thing that troubles me about it is that like if I have a concept that does not subsume any other concepts, and then there are changes that it can subsume some other concept, then I can add a new overload that would not be ambiguous with it, and I might not want that. Like you've now given somebody the ability to write a new overload that's not ambiguous, and that might be surprising.
I don't think I entirely followed that, but
I can show you an example.
sure. Other questions? Niall.
So I thought that was a good talk. I suppose my main real issue was about how you characterize the expressivity part and the trade-off between it and refactorability. I think you're off base in that slightly. I just want to explain where I would disagree with you in that. For me, the improvement in the technology we've had in software engineering, practicing, the fundamental building blocks, as of abstraction.
I think you mean programming.
Well, sorry, what did I say?
You said software engineering. The units on those are different. Squares are not cubes.
Let's not get into that right now, but let's get into, the point I was going to So you always have this budget of degrees of freedom versus points of concrete immutability. And as you're designing your software, your expertness, this whole point where people pay you to go and do this stuff, is to choose the correct, well, a somewhat ideal set of degrees of freedom in the areas that you think the software is going to grow over the next 10 to 20 years, whilst sacrificing in exchange for those degrees of freedom points of concreteness that will be immutable without throwing away the software and having to do it again completely from scratch.
Yep, I buy that.
The difference between someone inexperienced, especially someone who's not far out of university, is they'll choose the wrong degrees of freedom. So they'll choose all of this fancy stuff a lot of time, or maybe they make it too simple, but the degrees of freedom will be off relative to the problem being solved in question. And
I will point out none of this is on the mic, so this is a very long silence for the video.
okay, I'm sorry for the video. I don't know, hopefully the microphone. For me, that's the key part here. And because if you understand software in those terms, if you want to change, like you've done with Abseil, right? So Abseil's had, a beginning use case when it was first designed, right? And it was sort of pre-standard, whatever else, it's been upgraded over time to handle new things and new standards. And there's something you encounter a lot of big multinationals. You find a similar thing. You'll find that there's a vocabulary library, an abstraction library. Often, sometimes there's more than one abstraction library because they've abstracted from different teams. And it'll be merged. Rather than merging the abstraction library, they actually just have 5 abstraction libraries. So when you're getting the multiplication of vocabulary types, you get 4 string view implementations, all different in various different ways, some of which actually corrupt memory in various random fashions, right? And then patched around all that stuff. For me, when you start getting into that kind of world, my biggest advice I have always given to management, and to date I have always been ignored, is it's time to start thinking about breaking bits of sections off. So you carve out a section of software. You say this bit of software is going to be retired, as in we are going to kill it. And we're going to completely rewrite it. That section of software will be broken off in new code, and that's going to be our new broom handle as part of the broom. And we do that, and we next break off another section of code, and we're now going to attach that from the rest of the code. We're going to rewrite it completely from scratch, and we proactively rewrite completely working and fully debugged code as a sequential period over time. Now, John Parents talked a lot about that as being the thing that we should do for longer-lived code bases. It's very, very hard to get management to buy into and do it, because nobody likes rewriting code that has no bugs in it, right? It's been debugged already. Yet, I still find increasingly that if you want to maintain a code base over 20, 30, 40 years, and you want to have that be high performance, have some measure of working on new compilers, which was written for compilers that was in the 1990s, and not having to say strict data, and not having to say optimization, and all the rest of this, I find it personally an unavoidable thing. I was just wondering what your comment would be on my opinion on that, relative to your experience in it. So I saw you disagreeing with me a little there.
I have never encountered a rewrite that was across the whole organization actually cheaper. Like,
I'm not saying it's cheaper.
I'm saying cheaper over, cheaper over the total cost of ownership, right? Like, the reason that I talk about refactoring methods like this instead of, I introduced a new one, hey, I'm going to tell everybody you should use the new thing, right? Every time that you ask order n engineers in your organization, order n developers in your organization, to stop what they're doing, learn your forced mandate, your churn, execute a change locally, they're all doing that for the first time, right? You're paying the startup cost, you're paying the activation energy on every team that you have foisted work off onto. As opposed to, I have a team of, I have 4 teams of roughly 40 people total, and we do all of the API infrastructure work for an active developer population of like 15,000 people. We just do the work out from under you, and we get vastly, vastly more done, right? And that is not the model that everyone has followed, but more on that in this book. No. Other questions? But as to your notion of expressivity and design constraints and things like that, I think there is a very good point in that, which actually goes back to one of the earliest pieces of wisdom from one of my mentors at Google he described it in slightly colorful terms. Every code base is granted at birth a certain amount of fertilizer. If you are wise, you fertilize the garden, you fertilize the infrastructure, and a garden grows. And if you are foolish, you smear it all over the walls, right? Like, you do have to absolutely know where to spend those degrees of like constraint and expressivity. And my concern is, like, when we use the very abstract things, we are trading short-term expressivity for, like, we're spending the fertilizer on that instead of our ability to eventually change anything. And the model that I always go back to, that's like the first chapter in the book, like, what is the expected lifespan of your program? Over the expected lifespan of your program, you have to be capable of reacting to change in everything below you, right? Failing to be capable means that you are placing an existential bet that it's never important to do so, right? When a security problem, when Heartbleed or Spectre or anything like that comes out, right, you are betting that that isn't the end of your business model, right? If you are capable of change, if you're practiced in it, right, then maybe you can react and you can dodge that, right? And so if you have a short, I'm going to throw this away in 5 years, then maybe it doesn't matter, right? But like over a long enough time period, right, I believe that you absolutely have to achieve sustainability, not in terms of green energy and everything, but in terms of I am capable of reacting to the change that comes along. And I've only ever seen that at scale here. And that's why I speak the way that I do. So, yeah.
When you're dealing with an organization and you need to do a change, you need to decide whether you're going to do it in a break the world and let people sort it out as a priority. It is a possible thing to decide. Or you're going to do it this way.
Right.
What size of a team impact, org size, things like that, is the tipping point between those two?
In our organization, we actually have a thing called auto rollback, which is if the CI system detects that your change broke the build for more than N people, or for more than N targets, then your change is automatically rolled back. And I honestly don't know what N is right now. Like, it fluctuates depending on who's arguing at any given point in time. But like, it shouldn't even really be a matter of like discussion. Robots are much better at that. Like, just roll it back. And one of the nice things about most...
About that, it's about making people fix their stuff, because that's cheaper than making it multi-step.
Citation needed. Like, I'm not sure that it ever is. It's cheaper for you, but it's not cheaper for the org.
For some orgs it is, and I'm asking whether you know where the tipping point is.
I don't know. That is outside of my experience because I've never encountered a scenario where it felt like it was legitimately cheaper to make a breaking change and force everyone to react. Because, like with deprecations, for instance, right? You say, everyone has to make this change before this date, right? Otherwise, I'm going to break you, right? And that sounds great in theory if all of the impacted users are leaves, right? But every single time that you force a build break, right? That's not how graphs work, right? Half of the teams at most are leaves, right? Just looking at graph growth algorithms, right? And if you miss the being lucky and only impact one leaf team, right? Then trivially, it is obvious that the majority of people impacted by a build break are bystanders, right? Most of the people that are impacted, like their build has been broken by your change, had nothing to do with the offensive, you didn't react to my deprecation in time, right? And that is bad ecosystem management, right? If you can if mostly you're hitting bystanders, it's not a great targeting system, right? And like, I have not found a scenario where I was comfortable with that. So I think we are out of time. Thank you all very much.